We assume that modern science and space agencies have the entire planet actively monitored, but the data those agencies collect is temporally coarse. Their models update on institutional cycles measured in months or years, missing the immediate day-to-day shifts happening on the ground. Looking at a NASA satellite capture like this, you see sweeping macro-level terrain, but you get absolutely zero human-scale detail. We can observe massive weather systems, but we cannot see the exact soil pH on a single acre of farmland. Before modern satellites, mapping the environment meant rooms full of USDA clerks manually processing paper surveys. We have upgraded the technology since then, but that legacy of institutional delay remains baked into how we gather environmental data. Relying entirely on top-down observation leaves a massive blind spot. It cannot answer the real-time questions of the people actually living and working on the land. Down on the ground, farmers, foresters, and landowners are dealing with immediate environmental anomalies every single day. They are actively asking specific questions. Why is this vegetation declining? Is my local water contaminated? Is this weed an invasive species? The current solutions involve heavy friction. In many parts of the world, agricultural extension services are thin or non-existent, and we cannot realistically manufacture and deploy billions of dollars worth of physical sensor hardware into every field on Earth. We need a continuous ground truth data network. To build it, we need a frictionless way to collect signals from the people who need the answers most. The ingestion tool is already in their pockets. Telegram. It's a messaging platform with 1 billion users, zero onboarding friction, and massive adoption in agriculture-heavy regions across South America, Africa, and Asia. A user simply opens a chat with the LeafEngines bot, snaps a photo of a struggling crop, or types a basic question about their local soil. The system instantly returns actionable intelligence. The user's raw photo translates into a data card identifying the exact plant species, along with local soil match, climate fit, and water sensitivity scores. By delivering answers instantly and for free, the platform turns every user's smartphone into an active environmental sensor. But the interaction does not end in the private chat. Every single query triggers an automated architectural process. The system strips all personal data, transforming the geographic and environmental information into a standalone, indexable web page. That individual node automatically cross-links into massive taxonomies, connecting directly to local water quality and satellite history. As queries multiply, they compound into thousands of structured pages. This architecture captures scattered human curiosity and uses it to automatically build the largest environmental directory on Earth. Every one of those generated pages represents hyperlocal, monetizable market demand. If a geographic cluster of low pH soil queries heats up on the map, that directly translates into latent demand for local soil testing labs and agronomists. Those vendors pay for premium placement on these specific pages, or pay per lead to connect directly with users. Free intelligence builds the directory generates demand signals, and revenue funds global expansion. Zoom out to a multi-year timeline. When millions of these commercial data points accumulate globally, they create a continuous record of what environmental conditions matter to whom, where, and when. It enables Z-score anomaly detection. This is a statistical method that flags sudden spikes in specific queries as leading indicators of environmental stress. This chart compares user behavior against official declarations. A rapid climb in people asking about drought-tolerant crops signals a regional water shortage weeks or even months before government agencies issue an official drought warning. Those anomaly heat maps have broad dual-use applications. Public health officials can track water contamination clusters, emergency managers can anticipate disaster response needs, and conservation groups can prioritize land acquisitions. The accumulation of these micro-interactions creates a perpetual correlation matrix, a planetary sensory network that functions as an independent validator for regional climate models. Look at this historical water pollution control meeting. Environmental policy and regulation have traditionally moved at an agonizingly slow pace, relying on static data. LeafEngines, on the other hand, operates in real time. Because the architecture uses SHA-256 hashed identifiers, a cryptographic method to anonymize users, and aggregates data at the county level, it is completely privacy-preserving. That makes the entire corpus viable for public interest research. Over decades, this becomes a generational historical record, tracking exactly how human attention and land management shifted alongside a changing climate. Because this stream captures phenological shifts and soil trajectories in real time, it provides the granular regional calibration required to train next-generation Earth system models. LeafEngines is a self-sustaining nervous system for the planet, powered entirely by everyday human curiosity.